Hello again, everybody. I'm Michael Linky, and on behalf of the Australian Institute of Architects, welcome back to today's Lean In session. In today's program, we welcome back, as you well know, Timo Bleeker, focusing once again on his follow-up to his initial session that he did with us last week on passive house design. So in today's program, Timo is going to feature project case studies and showcase examples of how effective passive house consultation and considerations are achieved during the project planning phase, in addition to the benefits that it can offer to the design team. As always, this session is being recorded, and a copy of today's session, together with the slides that Timo is going to present to us shortly, will be available on our dedicated COVID-19 response page as well. I'll be curating Q&A for Timo as always, so if you have any questions, the chat box down below is your friend, so pop any questions that you have for Timo in that box, and then I'll go through them with him at the end of the presentation. So a little bit about Timo Bleeker. We welcome him back, as you know, from last week, but I'll tell you a little bit about him. So Timo is the Director of Idealings Architecture. He graduated in 2003 at the University of Applied Sciences in Bremen in Germany with an International Engineers degree in Architecture. Back in 2009, he then moved to Australia, and in 2013, Timo earned the title of Project Manager with the globally respected Project Management Institute, and then he went on to become certified by the Green Building Council of Australia in 2017, before becoming a member of the Passive House Institute and receiving the Passive House Designer title in 2019. And he joins me now from Perth. Timo Bleeker, welcome back to the program. How are you today?
I'm good, thanks very much, and thanks for getting me back in. I'm very pleased to talk to you again. Very pleased also that so many attended last time, and as I think there are a lot of people attending today as well. So very welcome. I'm pleased to have you back here and have you here at the Q&A session. Just a quick word. Yeah, I'm a bit better than a week ago, where I had a little cough. Be assured it was not COVID. It was slightly little cold, as you get it from your kids sometimes. So all good now. Yeah, I dive into the presentation. I have a little presentation discovering two passive house consultancy case studies, and showing you the value of passive house consultancy for getting appointed by a homeowner or getting appointed by an architect, and the slight difference there. And then we dive into a Q&A session and address a couple of questions that you had last week, and then probably further questions that you might have today. So the consultancy projects that we delivered for residential and mostly educational projects, targeting all the passive house standard, and we are using the passive house principles as our reference. A preliminary passive house planning package assessment has been developed for all those projects, providing improvement options to that given design that we assessed with the client or the architect, meeting their specific needs and budget. So the first case study was an appointment by the homeowner. It was a Class 1 residential building located here in Perth, WA. And it was a given design that we received at the end of design development stage. We need to say it was almost ready to be costed by a builder, when the client came across the passive house principles and in the internet, and Googled us basically and found us. So they got in contact and basically said, "Oh, can we improve our design a little bit further?" So we did that and assessed it via the PHPP, and did a preliminary assessment and an improvement advice. So basically, we got included into the project at the end of DD, and then further on later at contract documentation, the tender process, and we will be attending to the construction phase, giving advisory and airtightness testing, etc. So the task was to get a more energy efficient building, to improve it. And the most cost-effective options that we proposed were improved insulation, a reduced and better performing glazing, additional shading, and a different material choice. Sorry for the little cough. And the outcome was basically this. On the left-hand side, I just repeat what the passive house criteria are. So for heating, cooling demand, 15 kilowatt hours per square meter and year. A frequency of overheating less than 10% and an air tightness at 50 Pascal of less than 0.6 or 0.6 air exchanges per hour. So the existing design that we received from the client, we assessed that via PHPP, and the outcome was 32, 35 kilowatt hours for heating and cooling. We had 30% overheating. That's quite a lot. So calculating that back basically as we did a week ago for that 8 months, that would basically be an entire day being over 25 degrees for those 8 months. And we applied 10 air exchanges per hour as the NCC 2019 requirements that are newly introduced last year. They are not applicable for WA yet because they decided to postpone that, but I believe for all the other states they are applicable now. So we applied this as the minimum requirement now, basically, and that's included in those numbers above. After we assessed the existing design, we then assessed improvement measures. So we dived into the better insulation, glazing, shading, material choices, etc. And the best performing one to the most effective cost option got us to 13.2 kilowatt hours and 8% overheating. And we now applied the 0.6 air exchanges per hour as the passive house principles. So if we would leave that as the 10 air exchanges, the numbers would be higher by quite a bit. But because using the passive house principles as a base, we came to those numbers. The air tightness test that will be done on this building in the future, where we get. So we hopefully, and I'm quite certain that we get to those numbers on the right there, will show how good the building will be. The second case study was for an architectural office, and it is a school admin building, also here in Perth. We got involved early in the project at schematic design already and gave some advisory on the design and could do the PHPP preliminary earlier in the project at concept design already, not at the end of design development. So the initial design was developed with the architect. The outcome was quite a bit more compact design. And this design was then later gone through the PHPP software, and we improved that further to reach a really low overheating. The numbers are basically as follows. The criteria is on the left, and the existing design that we did with the architect already had a performance of 21.5 kilowatt hours, a frequency of overheating of 10%, and we again applied the 10 air exchanges as the NCC sort of standard now. So we see that when getting involved earlier in the project, the design already can be done to a better energy efficiency. Okay, to a better energy efficiency. So the rework to get improvements, added to the project, as we've seen here, this involved quite a bit of rework and adding items to the design of the project. When being involved earlier, there's less work to do to improve it at the end. So the improvement measures through the PHPP got us to 17.1 kilowatt hours by an overheating of 1%. So that's really low. There's almost no overheating there. But we basically accepted being over the passive house threshold for the heating demand. That's mainly because of shading elements that we added. So we don't get as much winter solar radiation in, which increases then the heating demand. But the client was happy to accept that. They are likely to put solar panels on the roof to use that for heating. these were the two case studies that I just wanted to to highlight. Now I dive into a couple of Q&As or a couple of questions that came up last week. There was a question like this, and the yellow highlighted bit is basically the core of that. It's directing to say the section J. And he was saying, I contend that Australia's Section J addresses energy efficiency from the wrong standpoint. The lack of ventilation and limits of glazing will lead to condensation and mold growth. I believe there will be a lot of sick housing in the near future. Comments? I mean, the passive house standard works as a whole and is best applied as a whole. So if we are sealing the buildings, we are addressing basically the drafts and uncontrolled ventilation, for example, and we are addressing damage to the structure. But we need to look at the whole we need to look at the whole picture. And at the moment, the NCC is only applying part of that. So they have now added air tightness to the mix, but they are not, for example, looking at thermal bridging yet. And windows, when they are just single pane and frames are not thermally broken, they basically function as a thermal bridge as well. So they are not addressed. So the coherent outer envelope is not addressed. So when we do parts of this, we might get problems with mold build up still. Because we're just doing one puzzle piece, but not the other puzzle piece. So we probably should leave the NCC what it is from a thermal point of view in progress framework and go beyond it and apply a solution, a building solution that gives us a building that gives us health and comfort and is financially viable because of operational costs. So that's where we get the better outcome at the end. There was another question asking, maybe not too relevant to subtropical climates like Brisbane and North, I guess it's North Queensland, where it doesn't get too hot and too cold for most of the year. Cost to benefit may not warrant the payback in saved energy. I would ask the question if in the areas you always have the air that you basically like 24/7, or when you live in an area that have odors or fumes, etc. in the air, passive house still helps you because the HRV filters your air and makes it cleaner basically. And I would also basically ask I would basically still say the humidity, the humid hot air gets into your structure, meeting your cold air-conditioned air that sits inside, and there might occur a problem amongst the structure when condensation could be reached. So it's basically the opposite of the situation that we are facing in the southern Australian area, here in Perth, Melbourne, and so forth, where the moist is usually coming from the internal space into the structure, and the tropical climates that might come from the external space into the structure and might condensate somewhere there. So you still want to address that and consider that. I remember when I was in Brisbane and Cairns, we were usually sitting in buildings that were 24/7 air conditioned. So they are colder than the outside. Another question was, so the idea there is a light bulb of 50 watts running 24/7 for the heat exchanger. Is that correct? Can you turn it off and choose to open the windows? Yes, the core idea for the heat exchanger or for the heat recovery ventilation is there's a bulb 30 to 50 watt running your ventilation basically. That is correct. You can turn it off if you choose so, whenever you want, and you can open the windows as often as long as you like. Yes. So it's flexible. Our electrician, 25 years experience, was surprised that we wanted airtight switches and power points. He suggested applying silicone to the PowerPoint box from the inside once the cabling is in place. Is this best practice? No, it's not. Silicon is not considered airtight, and mainly because of the reason that it's not, after a while or after time, it's tends not to adhere as good anymore, especially to smooth surfaces like plastic or aluminium, etc. So you will have gaps in there where uncontrolled ventilation can come in. There are products on the market like grommets or molds that you can install into the walls, and the GPOs and switches are installed into those. They are airtight, certified airtight solution. They're available on the Australian market. Which wall system offers the best performance in terms of airtightness? Reverse brick veneer, can't use in this gentleman's or lady's build, or insulated double bricks. Insulated double bricks, I mean, bricks and mortar is usually considered airtight. However, cracks are an issue that might occur at older buildings, and getting penetrations airtight because it's a rough surface. So when you need to penetrate those bricks with pipes or with GPOs or light switches, this needs to be planned carefully. Reverse brick veneer, those veneers are usually sorry, getting glued to a substrate. So if this substrate is airtight, let's say for example CFC or plasterboard, etc., this can then be better sealed or more easier sealed with elements or products that are on the market than the insulated double bricks. So I would tend to the brick veneer between those choices here. This was the question I chosen from last week's attendance, and I would say thank you and ask if there are any further questions.
Thank you, Timo. We've got a number of questions which have come through the chat. And first of all, I wanted to start just with a question from Wendy. And these are questions that have come in overnight to me on the email. So Wendy's first question to you, Timo, is how can you apply passive house principles to multi-residential projects? Wendy works in a lot of apartment design. So what's your question, what's your response rather to Wendy's question on that point?
You can apply the passive house principles either to separate apartments, so 1 or 2 apartments as a separate item, or to the entire building. It's both possible. So for example, a mixed-use building where you have retail at the bottom and residential at the top, and you only want to apply passive house principles to the apartments, you basically just do that. The challenge there lays in the detail. So you basically need to look at where your thermal envelope lays and where your airtightness layers are laying. The walls that are connecting the, let's say, ground floor retail area to the upper floor residential area might constitute a thermal bridge there. So there needs to be solution found. If you just do one apartment at the very top as a passive house apartment, it's the same thing. It comes to the detail and the thermal bridges and the connection points, but it's entirely possible, and to get just that part certified is also entirely possible.
Let's talk about airtightness, and especially as it relates to HRVS, heat recovery ventilation systems. You mentioned that natural ventilation, this is a question that came through again overnight, but we're reverting back to last week's session when you talked about natural ventilation being encouraged. How does that impact the running of HRV, and does that mean that the HRVS runs constantly?
You can run the HRV constantly while you have your windows open, because it draws so less energy, as I said, 30 to 50 watt. You might not run, all the time to the HRV, switch it off and on and off. There can be a switch installed somewhere central in your building that is easily accessible. So when you open your windows, you just switch your HRV off. That's a possibility. But you can also let it run 24/7. The buildings that are certified, many of them have it run 24/7. and they are not, the energy use is not going over those 15 kilowatt hours per square meter in year, which is really low. And they have the HRV running 24/7 basically. So after a while, though, the owners of the certified houses, they usually didn't switch that off anymore. They had the same concerns at the beginning, but after a while they didn't, because the energy use is so low. And yes, you can open your windows as long and often as you want. Obviously, the heat recovery would work then less when your windows are open, because it's sort of ventilation that comes from the outside. The heat recovery works best when the windows are closed, and you've got your air tightness basically.
Mm. You're talking about the motor operation, I suppose. Is it consistent in how it runs? So does the motor use fluctuate at all based on indoor or outdoor environments at all?
No, it doesn't. It's
Okay.
The temperature or conditions that are inside or outside don't affect the running of the HRV unit.
Mm.
So if you have 40-degree heat humidity outside, or you have 20-degree dry climate outside, doesn't affect it.
Mm. Let's talk about range hoods in the kitchen.
Yeah.
How are they handled? I mean, do they have to be recirculating to comply with Passive House principles? And how does that, I suppose, sit with the National Construction Code's guidance?
Yes, so if they're connected to external, they would need to run through, I forget the English word for it, a buffer, basically an item where the air is running past to get warmed up. So if you connect that straight to the outside world without that little buffer in between, then you would have an air leak, which is one of those leakages that you don't want for air tightness, and you won't get your air tightness values that you need.
Mm.
I mean, Passive House is not too much promoting those range hoods. You can do those reverse cycle ones where they just filter the air. That's an option. And there are also options where they came now new to the market, where cooking plates have ventilation inbuilt, so you don't need a range hood. They're inbuilt in the cooking plate.
Okay, thank you. We're going to stay on this subject just in terms of residential dwellings, wet area exhaust systems. I understand that the HRVs extract from these spaces. Does
Yes.
that intensity of extraction, the intensity of the extraction out, does that increase during times of use? And does it have a manual switch within a bathroom setting?
Yes, it does. So
Okay.
if you are in your bathroom and you want the exhaust air to be boosted, there's a boost switch on those HRV units that you can press, and it will increase the ventilation and the exhaust rate through the system, and gets it out of the room, or out of the entire building.
Mm.
The air volume that the HRV is doing usually is about the 350 cube per hour mark in a boost function. I understand that the exhaust fan might have a slightly bigger cubic meterage per hour, but that can be easily adjusted when switching on the boost function, for example, at the beginning of your shower session and not at the end, or you just let it run a little bit longer. The energy that it uses for the boost function is marginally higher.
Mm. There's a question from Diego on the chat, and it's a great question. He talks about retrofitting. So let's say there's an existing dwelling. How easy is it to retrofit a HRV unit into an existing dwelling? Is that something that's fairly straightforward? What type of pre-existing system then, he asks, or ducting do you need if we are going to commence a retrofit?
Yes, it can be built in a retrofit, for sure. We need to look at all the penetrations and how to reticulate the piping throughout the existing building. And you would want find an ideal location for that HRV box inside the building. It can be outside the building, but then the pipe work into the building needs to be insulated. But yeah, reticulation of the pipework is a bit of a thing. And if you install it into an existing building, we, excuse me, we also need to achieve our airtightness rates. Usually it's said HRV unit wants to have an air tightness of 3 air exchanges per hour. So to achieve this, the existing building would need to be retrofitted the same way to achieve this. So we would need to look at the details, basically.
We've got a number of people on this session today who are, as you will understand, all over Australia, and I'm going to break them up into tropical climates and non. So I want to concentrate a little bit, first of all, about the tropical climates. We've got a number of members here on the line from the Northern Territory and from Queensland. So let's start with them. So I want you, and this again, cast your mind back to last week when you talked about your comments in relation to the air tightness layer in a subtropical or tropical climate. And you mentioned that in Perth, Melbourne, Sydney, Tasmania, it's on the inside of the insulation, but in more tropical climates, it might be the other way around. Is that correct? I just want you to clarify that comment that you made last week.
Yes, that might be correct. The reason is the pressure difference between outside and inside. So the outside, the moist laden air, external air, might tend to come into the building rather than going outside the building. So this would need then to be addressed. This would need to be addressed, and the air tightness layer might then need to be on the outside. So what we usually say is, or want to do, is a WUFI calculation. That's a calculation to find out where your condensation points are within the walls, and that would tell you where the moist laden air wants to go, from outside to inside or inside to outside, and determines if the air tightness layer needs to be on the outside of the insulation layer or the inside of the insulation layer.
This is a question from Darwin on the chat. He's based in the Northern Territory. Look, and his question is, look, how do passive house principles apply to cyclonic regions? Let's say, Darwin, where most of the new properties that are being developed are blockwork built. They are constructed in terms of steel, steel roof construction structures along those sort of lines. What would your response be in terms of architects looking to develop both residential and commercial properties in the top end?
I mean, this situation, the climate situations, the general climate situations are fine. Passive house principles apply to those. When you get those heavy storms up there, this is rather a structural questions that need to be applied to those buildings, so that they are basically not getting blown away, in simple words. In terms of the performance of the outer envelope that it's getting built to the passive house principles, it remains the same principle. So dealing with the thermal outer and inner environment stays the same principle. Storm conditions might be a structural question for the planners.
Okay, let's move south. I'm in Melbourne. Yes. A number of our members are in Melbourne. I've got the heater on under my desk here, as warm as possible. We've got a question from Stephen on the chat, and Stephen says, look, he's looking at developing geothermal heating and cooling to his own house. He's based in central Victoria, very cold climate, as you can understand. What issues would Stephen need to take into consideration when thinking about developing a geothermal heating and cooling system into his own property?
Geothermal can be connected to the HRV system. It's got done at projects in Europe, more commercial projects, more bigger projects, because usually geothermal is quite cost intensive to be installed. So for residential, I haven't seen that yet. And I need to honestly say, dived into that topic too much. It can be done. It might be too costly for residential class 1 buildings. It might be viable for more commercial projects where you have more dwellings and you have a central heating unit. So the heat recovery unit would then be bigger, and it would serve, for example, several dwellings or several apartments. And this then becomes a bit more viable. But this is just general information I've got. would need to look into that further. I haven't come across that in my own projects yet.
That's fine. Look, in Melbourne, we're staying here in the state, selfishly, but you know, a lot of construction work in Melbourne is, especially, it's become quite trendy with our clients in terms of timber floor construction. That, you know, they like floating floorboards, they like herringbone design, whatever it might be. This is a question from Kath, and Kath raises a good question. This is an existing timber floor construction in Melbourne. What do you recommend is the best way in terms of providing insulation? She says, look, installing insulation under the floor between the joists obviously still lets air through. So would you recommend building up over the existing timber floor with maybe, say, another set of joists and flooring, or would it be useful maybe to seal the existing timber floor, Timo, beforehand? And what if that's the case? What's your response?
It would probably be better sealed beforehand. So she wants to install the insulation underneath the floorboards between the joists. That's what I understand now. And then add to it. So the insulation would be underneath. That's fine. Then the air tightness layer needs to be on the inside of that insulation layer or insulation face. So we would need to think of how we get that done on the floor. If she wants the timber floors, they are leaky basically. We would need to address that underneath. In a retrofit, that can be quite intensive work to do that from underneath. It can be done from the top if these timber floorboards are not wanting to be seen. Often they do want to be seen, so that makes it a bit difficult to install the air tightness under those floorboards. You would need to wrap it, you know, around the joists all the time, and then get the insulation in between. But still look at a continuous insulation layer that you don't get or you don't build yourself thermal bridges in and potential moisture problem.
Mm. A question from Ruth, and this is an interesting one. This relates more so to the air quality within the home. So Ruth asked you the question, Timo. Look, she understands that the air outside is safer than the internal air from the volatile organic compounds that come from much of our furniture, you know, the rubbers, the foams, you know, those sort of things, those organic compounds, you know, that often float around a house without our knowledge. And so her question relates to that. How is that handled within an enclosed system when VOCs are becoming more prevalent with all of the sort of chemicals that are in our properties?
Yeah, the HRV system would filter part of this out, to be honest. They have a filter on the incoming air and they have a filter on the outcoming air. So those VOCs, after time, they get filtered out. And after years, when the materials release less and less and less VOC, your internal environment basically becomes more and more healthy, and it gets filtered out constantly, basically. Otherwise, if you don't have an HRV, it basically sits in your room. You open your window, yeah, then it gets taken out. But when you have your windows closed, nothing happens to it. It just hovers there. With an HRV unit, because it provides 24/7 fresh filtered air and conditioned air, it takes this out. That's another benefit of the HRV unit. It not only preheats and pre-cools it, it filters items out in the air that you don't want. And VOC could be one of them.
This is another comment from Priya Lucy on the chat, and she talks about the traditional buildings that we have here in Australia, as you well know, are made with bricks, they're made with glass, they have good cross ventilation. She notes then that it says, look, but last year's summer, one day the temperature rise when it was at its hottest, you know, obviously was quite uncomfortable. How can these houses that are traditional in its element, that they're traditional in its design, how can they be more passive in the future when we are dealing with ever increasing climate change?
Are we talking about existing building stock or new building stock?
From what I'm reading on the comment, I imagine that it would be existing property stock.
Yeah, so we're talking about retrofits. Yes, retrofits are, you know, its own beast, basically. They can only be improved as much as you can do. So you can apply insulation, you can apply air tightness, you can apply double glazed windows, you can put an HRV unit into it. but often when it comes to thermal bridges, you can only go as far as you can do. When, for example, you get your roof joists or ceiling joists meeting the roof rafters laying on your walls, on the top plates. These are often difficult details and joints to insulate as a retrofit, also as an air tightness layer. So that needs to be looked at in case-to-case basis, how those buildings got constructed, and do that as good as we can. But we can certainly improve every building to the better and get them at least, you know, to a low energy standard.
This is a question from Mark on the chat, and his question to you, Timo, is this: what are your thoughts? And I'm presuming you're going to be in agreement with this. What are your thoughts in regards to engaging an experienced passive designer and a builder at that concept design stage? Would it make the outcomes more cost effective in both the design and also the construction phase of the project?
Yes, it would. It would very much, because at the beginning you don't only get the aesthetics, so the design, you also get the thermal performance puzzle. I always say you get more puzzle pieces early in the project. You get the design, the aesthetic, you get the puzzle piece of the thermal performance of the building, and you also get the puzzle piece of the cost to it if you involve the builder early. A builder is very close to market prices, so he knows what the building costs and how to put it together. You can also advise strongly on best construction methodologies, for example. And to get, you know, all those parties early together early in the project has a big effect or great effect to the client. Getting into a position where they can do informed decisions about design, about the thermal performance of their building, and the related cost to it. So that avoids, you know, rework later or replanning later, or you know, less than good outcome later. So yes, strongly promote the idea of getting a builder involved early and getting all the stakeholders and parties involved early in the project.
All right. Well, thank you, Timo. I'm conscious that you're still getting over your chest infection, which is not COVID.
No,
for those who are expressing concern. We were there. For those who have got any other questions, Timo, what's the best way to get in contact with you? I presume just the contact details that are on the screen at the moment?
Yes, exactly. So they can email us. They can give me a call as well if they want to discuss something on the phone, and they can get onto our webpage to get more information. And that would probably be the best way to get in contact.
Okay, great stuff. Thank you, Timo Blinker. So for those of you who are asking, just as well, just to reconfirm, yes, this session has been recorded, and the session will be available later on this afternoon on our COVID-19 dedicated page on the Institute's website. So just go to architecture.com.au, you'll see it slide through there, and you'll see the COVID-19 page. Click on that, you'll get the lean-in recordings from there as well. These slides that Timo's presented to us today as well are also going to be available. We'll upload them very, very shortly on the website as well. So that's really it for today. Thank you very much, Timo, for joining us. It's always great to have you, and thank you so much for coming back in the second week too, just to cover off some of those questions that we had outstanding, and for you to take us through those case studies as well. It's been really appreciated. Thank you so much. Do go and take some time to not talk and to feel better. I hope you and your little boy recover soon. But from Perth, Timo Blinker, thank you very much for that. So do join me next week on Tuesday. We're going down a different direction. We are actually going to be talking about equal pay. This is an interesting one. We're celebrating gender equity next week by teaming up with the New South Wales Gender Equity Task Force that we operate here at the Institute, looking really at the disparity in pay between men and women in the architectural profession and what we can do to bring parity to both genders. So do join me on Tuesday. That's going to be a really fascinating session, something a bit different for us. We like to sort of be quite varied in our content, and hopefully that will be of interest to you irrespective of your gender. So that is it for today. As always, I have been Michael Linke here at the Institute of Architects. Great to spend some time with you. Thanks so much for spending the last 40 minutes or so with me. Don't forget, next Tuesday, do join me again. Keep an eye out for that email promoting that as well. Until then, do take care, stay safe, and I'll see you at a future Lean In session. Thanks very much.